Alrighty, 3.1.2, solving linear equations continued. Now, this is very, very similar to the equation for 3.1.1, right? We're still going to try and justify, we're still going to try and solve, but these are some of the ones that have maybe more than one step to them, or are in a strange sort of looking pattern, things like that. So these ones, they're really nothing different though. So let's just go ahead and dive in. Solving equations. Like I said before, solving equations is always easiest if you start as far away from the variable as you can, okay? However, that doesn't really encompass the whole thing. That's just sort of a general rule of thumb. So here are some more in-depth solving instructions. You always want to first choose a side you'd like the variable to appear on with standard, syntax. We usually like the left, right? So x equals 2, x equals 3/2, stuff like that. Therefore, if you have variables on both sides, you really need to start with step 2. You add or subtract the other variable so that everything is on one side. That's pretty important. That's something we hadn't seen before in the last chapter, or in the last section, pardon me. So now we need to make sure it's all on one side. This third step is, again, simplify both expressions. So simplify starting as far away from the variable as you can, using your properties of equality, and then continue to solve the equation. So simplify each side, and then use your properties to switch stuff back and forth until finally you arrive at something like x equals 2. And then you should always check your answer by using the substitution property and substituting back in. Sometimes you can end up with two different types of solutions. Sometimes the variables drop out. Sometimes you end up with something like 2 equals 6, which means you have no solution. Just doesn't make any sense. Sometimes you can end up with stuff like 6 equals 6, and that is actually an infinite solution. We're going to see examples of both of those today, but just know that they do appear, and they have special meaning, so we'll talk about it. Alrighty, let's try out example 1. Solve the equation 5x plus 9 equals 2x minus 36. Not very different than the ones we were looking at last time. So let's set up a little table over here. Okay, and we'll cut it in half. We'll write equation, and we'll write steps. Awesome. And as always, we will start with the original equation. 5x plus 9 equals 2x minus 36. That was our original. Fabulous. Now, again, remember, there's a little bit of your choice here, right? The first thing we want to do is get the variable to one side. That was step number 1. We have a problem here because it appears on both. So if I were just to start by going as far away from the variable as I could, might think, where the heck would that be, right? Because it's on both sides. How could I possibly have the farthest away on both sides? So I'm going to start by getting the variable to one side, and then we'll see what happens from there. So I'm going to move this 2x to the other side. How would one do that? Well, you've got plus a 2x, right? A positive 2x minus 36 that I need on the other side. So if it's positive, meaning it's addition, I want to counter with subtraction. So I'm going to use subtraction property of equality to get it to the other side. Subtract 2x from this side, I'm just left with negative 36. Subtract 2x on this side, I'm going to have 3x plus 9. Awesome. Alrighty, next step, I want to get the x by itself, right? And I'm going to start as far away as I can. So I'm going to use the subtraction property again to get rid of that 9. Property of equality. And I'm going to subtract 9 from this side, which just leaves me my 3x. If I subtract 9 from the other side, I end up with, I believe, negative 45. Yep, negative 45. Just wanted to double check. Just in case, right? But, we should probably be able to do that. Alright, that was subtraction property of equality. When I use colors like this, it's very easy for me to track whether I've actually written down my steps. So if you want to use colors, that's fine. But I also see this sort of like boom, 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 boom thing going on here. So as long as that happens, that's okay too. You can use numbering. You can, as long as you have them all, it's really up to you how you want to organize it. But I like colors. I just like colors because they're easy for me. They're fun. Alright, last step. I need to get that x all by itself. So I need to divide by 3 to both sides. I'm left with x. Whoops, whoops, whoops. Just in case, I'm going to write down what I'm doing first. Division property of equality. and I end up with x equals negative 15, and I'm done. So it looks like negative 15. Let's just double check over here that that is indeed the answer. So 5 times negative 15 plus 9 is equal to 2 times negative 15 minus 36. What I've done here is I've done the substitution property, right? I took the original equation. I know that x equals negative 15, and so I should be able to plug in for every x a negative 15. Let's see what happens when we do that. Let's see. Negative 15 times 5 is negative 75 plus 9, and negative 75 plus 9, oops, that's 7, is equal to negative 66. Now, if x is truly 15, then the other side should also give me negative 66. So I have on the other side 2 times 15 is negative 30 minus 36. It is indeed negative 66. So it looks like x does equal 15 because it gave me something that made sense, right? Gave me negative 66 equals negative 66. Now again, that was a check. So I was just checking it. You don't have to do that step, but if you're ever wondering, like, okay, this test is 100 points, right, and I am solving this equation, and I need to know, does this actually work? Then substitute in and check your answer. If you get something like negative 45 equals negative 312, you know you didn't do it right? So if you need to check for a test, this is a very easy way to check if your answer is actually right, okay? Alrighty, let's try it again. I'm going to have, now let's do this good. Let's do this one together. So we'll set up a table, right? Equation on this side, steps on that side, and then we'll start with the original. So we want to solve the equation 7x plus 4 equals negative 9x. 7x plus 4 equals negative 9x. That is our original. Alrighty, now that was a setup, so I'm going to let you guys try from here. I want you to figure out how to solve this one. And this one may look a little tricky because you've got stuff going to the sides that may cancel out. So try it out and see what you get. Make sure you pause the video. Alrighty, so I hope you had a chance to pause the video and give it a try. Remember that you can add or subtract to either side, right? So if you wanted to move things over to the left, or if you wanted to move things over to the right and make it 0, that would be fine. Move things over to the right, that would be fine. In fact, I'm actually going to do that. However, if you wanted to keep the x on the left, when you added 9 to both sides, you'd end up with a 0. So you just have to be careful, okay? Just have to be careful. I'm going to go ahead and actually subtract 7x from both sides, though. So subtraction, property of equality, right? So subtract 7x on this side, I'm left with 4. Subtract 7x on that side, I'm left with negative 16x. Then from here, I will use division property on the right-hand side. Now you should already have a version of this on your paper, that's why I'm kind of going fast. Division property to get rid of the 16, and I end up with x over here, and then over here I end up with negative 4. And that would be awesome. That definitely tells me my answer. X, negative 4 is equal to x. But that's not really how I want to write it. I want to use symmetric property. Symmetric property of equality. To say that x is equal to negative 4. That's my final answer. I can check that out. Let's see. Check. 7 times negative 4 plus 4 is equal to negative 28 plus 4. Okay, what did I do wrong? Divide by haha, just kidding. Okay, so notice teachers make mistakes too, right? I was totally just kidding. because when you use the division property, right, you are not dividing 16 by 4, you're dividing 4 by 16, and so you end up with 1 over 4. My apologies, 1 over 4. So this ends up being negative 1/4. But notice how vital that check step was. I was going through that check and I said, wait a minute, this is not going to end up equaling each other. And I instantly knew my problem was wrong, right? So if you use the check step, you know that you've made a mistake. That's exactly what happened. So I'm actually kind of glad that happened. I'm not going to go back and edit over that. All right. So instead, let's check 1/4. Let's make sure 1/4 works, right? So let's check that one. We'll do check 7 times negative 1/4 plus 4 is equal to negative 9. That's the question we're going with, times negative 1/4. All right, so let's check this out. So negative 7 times 1/4 is 1.75. I'm sorry, negative 1.75. 7 times negative 1/4, or 7 times negative 0.25 plus 4 is going to be equal to, I'm tired today. Okay, minus 1.75. 2.25. Awesome. Alright, so if this is actually the true answer, then it should end up being 2.25 on the other side as well. Negative 9 times negative 0.25 also ends up being 2.25. So good. This one was the correct answer. That's nice. Check. Alrighty. Let's try a couple more. Set up our table so we can justify. Got equation, steps. My original equation this time is 2 times 3x plus 1 is equal to 6x plus 14. And over here we will write original. Whoa. Okay. I think this time I'm going to start with parentheses, right? So parentheses are always sort of the easiest thing to start with. You may want to get rid of them. We saw in a previous example that it's okay not to. Sometimes your problem is getting a little strange though. So I'm going to start by distributing those parentheses. Start with distribution, property of equality. And I end up with 6x plus 2 equals 6x plus 14. Awesome. Pretty good so far. Now I think I'm going to move all the x's to the left-hand side. So I'm going to subtract 6x over here. Actually, I'm going to write down subtraction first so I don't forget. Subtraction, property of equality. All right. So subtract 6x, I end up with 14 over here. Oh, that's interesting. Subtract 6x from this side, I also end up with 2. Does 2 equal 14? No, it does not, right? So first thing I'll do is I'll go back, check, make sure I didn't make a mistake. See, 2 times 3 is 6, 2 times 2 is 2. No, actually that looks okay. So this must be one of those cases that Miss K was talking about earlier. This is where you get something that doesn't make sense. In a sense, the variable has dropped away, and you end up with the statement 2 equals 14, which is complete gibberish. So this one has no solution. No solution. Bummer. Oh well, let's move on. This one, in other words, this one does not have any x that would ever make these two true. Just, it doesn't exist. Let's check out something similar. Let's try again. Maybe this one will work. Let's see. I hope this one works. That would be great if this one works, because then we've got this down, right? Then we can just make a table, we can solve it. I hope this one works. Steps. Again, we'll start with writing our equation down. So 3 times, 4x plus 2 is equal to 12x plus 6. That's our original. Alrighty. Again, I think I'm going to start with distribution property because those parentheses are in my way, so I'll try that out. Distribute. I end up getting 12x plus 6 is equal to 12x plus 6. All right, that already kind of raises my eyebrow a little bit. They're exactly the same. Interesting, but that's okay. So I started with distribution. All right, I'll just keep going like I do. So I want to get all the x's to one side. That's my next step. I'll try subtracting 12, and we'll call that subtraction property of equality. And when I do that, I end up with 6 on this side and 6 on that side. All right, so you may be thinking, oh great, another no solution. But let's look at this carefully. Does 6 actually equal 6? Yes, 6 equals 6, right? So this doesn't have any, it has no solution. This has an infinite number of solutions. In other words, it didn't matter what I put in for x, because I'm always going to get down to something that makes sense. And remember, if you have a solution, those are the ones that make sense. So an infinite number of solutions for this one. Since no matter what I plug in there, it will make sense. Versus the last one, where no matter what I plugged in, it never made sense, right? So if it never makes sense, no solution. If it always makes sense, infinite solutions. Alright. Now when it comes to no solution, infinite solution problems, this is the level of work I expect. You cannot just go through and write no solution to every problem. That just makes you look silly. Go through it. I want to see why you think it's no solution or infinite solution, okay? I want to see what led you to 6 equals 6. Alright, so even for these guys, you have to set up the table. Alrighty. So that's solving equations using properties again, right? So a little more complicated, some stuff that can happen. Next, we're going to talk about rearranging formulas. So if you have any questions at all, please make sure you pause the video and talk about them now. All right, rearranging equations. So so far we've dealt with equations that have one variable, right? One variable in there. You can solve out, get x equals 5 or 2, or you end up with some weird situation like this. Next, we're going to talk about something we call literal equations, which is still an equation, definitely an equation, but it's got more than one variable. So let's take a look at this one. Solve the literal equation for r. D equals RT. You may have seen this equation before. Distance equals rate times time. That's what this stands for. Distance equals rate times time. Now, and it kind of makes sense, right? If you go 5 miles an hour for 3 hours, you've gone 15 miles, right? That's how this equation works. This is what we call a formula. Sometimes you see formulas. And when we're solving these for specific variables, we're not going to arrive at answers like r equals 2, okay? All this is rearranging. Rearranging formulas, in other words. So we're going to use those exact same properties, because remember what I've been saying so far this chapter, variables are not special. They have to follow all the same properties of equality, just like variables have to follow all the same exponent rules. Variables have to follow all the same operation rules, right? They aren't special. They're really not. They're just numbers we don't know yet. So what we're going to do is rearrange so that we can solve these for a certain variable using those same equalities. It's going to look a little different because we don't actually know what d and t are. So we're not going to get down to something like 3, but we'll use the same idea. For this one, when we're rearranging, it's not really vital that we use our justification steps. We'll just talk about them, okay? It is always vital to actually justify, but here you don't need to spell them out. You can just go ahead and actually write it down. So let's start with d equals rt. You know what? I take that back. I'm going to make a little table. It's not going to take too long. We'll do it just this once. So this is original. Okay, this is our original equation. D equals RT. Now, the variable I'm solving for is R. Okay, so I'm going to write it in pink. That's the only one I treat like a variable. So the other ones are just constants, and I'm going to treat them like any other thing. How would I get R by itself? What would I do? I need R by itself. That's the goal here. So if I'm solving for R, that means get R by itself. Alright, in order to do that, I'm going to have to use that division property. I'm going to divide by t to both sides. I actually have no idea why I wrote it that way. So I'm going to divide. I'm going to use division. And when I do that, I divide by t on this side. I'm just left with r. And I divide by t on this side, I get d over t. Now, in the last problems, if I had something like 16 divided by 8, I knew that was 2, right? I knew that was 2, and that's okay. I can go ahead and make that step. I don't know anything about d and t, unfortunately, so I'm just going to leave it as d over t. And that's okay, too. And then I can use symmetric property to say that r is equal to d over t. Right? Symmetric property says I can write it in either way. Whoops, so sorry. Property of equality. Property of equality. All right. And that's how we rearrange. Notice it was the same steps as last time. It says this time there have to be more variables. Let's try out another one. We're not going to do a steps or a chart for this one, but the equation for perimeter of a rectangle is P is equal to 2L plus 2W. Solve it for W. Now, they tell us what it is, right? They tell us about the perimeter of a rectangle. Do they actually want us to find a perimeter? No, right? They just want us to rearrange this. So when you see complicated expressions you've never seen before, formulas you've never seen before, you do not need to panic, okay? You just need to read. If you read it, the only thing they want us to do is solve it for W. So even if we didn't know anything about what W and L stand for, it wouldn't matter, right? In this case, it means 2 length plus 2 width, right? You add up all the sides, but it wasn't really vital for us to know that at this point. Now, in a word problem, we might need to know that, but hopefully they'll explain it to us when we get there. The instructions will always tell you what you need to do. So let's take this equation. I'm going to use blue. P is equal to 2L plus 2W, right? Now I'm going to mark up which one I actually want. So there's W. That's the one I want all by itself. That's the one I want all by itself. So I'm going to start as far away from the variable as I can. First off, double check the variable is not on both sides. It is not. Okay, good. Now I'm going to start as far away from the variable on the left-hand side as I can. That would be the 2L. So I'm going to move the 2L over to the other side. I'm going to subtract, use the subtraction property, and end up with, P minus 2L is equal to 2W. I couldn't actually combine P and L because they're unlike terms, right? But that doesn't matter. It doesn't matter. I just wanted W to get more and more by itself. W is still on one side. It's still almost by itself. It's going to do one more thing, but I'm starting to get it to be by itself. Last thing I'm going to do is divide by that 2. So divide by 2 to both sides. You get P minus 2L. All of it over 2. When you divide to both sides, you have to divide the whole side, right? Is equal to W. And now W is by itself, so by symmetric property, W is equal to P minus 2L over 2. Again, one side did not end up very pretty. It's not W equals 5. It's not W equals 1/2, right? It's W equals this whole nonsense, but that's why it's called rearranging and not really solving, right? So it's kind of solving, but it's not really solving in a sense either. Alrighty. Let's do one more together, and then I will have you solve one by yourself. So let's try this one. The equation for area of a trapezoid is area is equal to 1/2 base 1 plus base 2 times height. Solve it for base 1. Notice that I knew what this equation was saying, right? I knew that A stood for area, and B stood for base, and H stood for height, right? Was that absolutely vital that I know that? No, it really wasn't at this point. I just have to make sure I'm solving for the right variable. But if you happen to know, maybe it can make it easier, right? Maybe it can. In formulas, variables always mean stuff. That's why they're called formulas instead of just equations. But really, again, it's not really the most vital thing at this moment. So let's take that original equation. Area is equal to 1/2 base 1 plus base 2 times height. And I'm trying to get base 1 all by itself. Now, you may be thinking, great, I have parentheses, I know what to do, I'm going to start by distributing things in the parentheses. That may actually be more complicated than some other stuff. Remember here that you have multiplication, multiplication. So I can get rid of these multiplications through division. I'm going to start with the H. So I'm going to move the H over. Divide by H. Divide by H. H. I end up with A over H is equal to 1/2 B1 plus B2. Because H was pretty far away from that variable. I wanted to start with something that was very far away from that variable. Next, I think I'm actually going to deal with the 1/2. Remember, 1/2 is the same thing, so I can look at this also as B1 plus B2 over 2. Those two are actually the same thing. That's why I've written them in the same color. When I see it that way, that kind of sparks into my mind that I can, if I'm dividing by 2, I should multiply by 2 and get rid of that. So I end up with 2A over H is equal to B1 plus B2. And now notice I've already dropped off the parentheses because they're no longer important, right? If I just have an entire side having parentheses on them, there's no reason to have them. And then lastly, I can get rid of the B2, and I end up having 2A over H minus B2 is equal to B1. Symmetric property says B1 is equal to 2A over H minus B2. And I am finished. Alright, so notice if I had started by distributing the parentheses, I would have ended up with a whole mess of other terms, whole bunch of stuff I didn't want, right? It would have worked out to about the same. We'd have to take a few more simplifying steps. You would end up getting the same thing. But if you can leave parentheses in like that, again, just start as far away from the variable as you can. Start away from as far away as you can. Okay. All right. Next problem: solve the volume of a cone for B. V equal to 1/3 BH. That's volume is equal to 1/3 base times height. Again, not necessary to know that. So why don't you guys try it out yourself now? Solve it for H. Or sorry, solve it for B. Pardon me. Solve it for B. Do what it says on the page. Solve it for B. Remember to pause the video. Alright, so I hope you paused the video. I'm going to do this right over here. So volume V is equal to 1/3 base times height. I'm going to do this the same way I kind of just did the last problem, right? I'm going to start with the thing farthest from the variable, quote unquote. Now they're actually both equally far, so I'm just going to start with H. Divide by H to both sides. You end up with V over H is equal to 1/3 B. In other words, V over H is equal to B over 3. Right? Because these two things are the same thing. So I've divided by H, and I end up with this, and I can look at it like that. I'll stick in red. Lastly, I'll multiply by 3 to both sides, so that these 3 cancel. I use the multiplication property of equality, right? And a B is equal to 3V over H, after that symmetric property. So that's what you should have gotten as well. Alright, so that's rearranging formulas. One last thing we're going to talk about is being able to not only solve equations, but translate them as well. Very, very, very beginning of the year, the very first thing we did was start talking about things that you can see them in English, and we want to translate them into math, right? So we want to translate them into symbols so that we can solve them easier, and then translate back. Think of it like Spanish, right? So if you're taking a language, maybe you're going to take it next year, it's very, very similar. You translate it into English, like, or how do you, I don't know. ¿Dónde está? Right? You translate that into where are you? You answer the question, I am here, then you translate it back. Estás aquí, right? Or estoy aquí. Same thing with math. Math is just another language. You translate it into symbols, you solve it, you translate it back. Luckily, you don't need to know 50 million symbols, right? Usually it's stuff like X, not ¿dónde está? But it's essentially another language. That's all it is. So we're just going to translate it, we'll solve it, doing exactly what we've done for the past hour, and then we'll translate it back, right? And translate it back usually doesn't even happen because it ends up being a number. So let's read this problem here. Example number 9. 2 less than 1/3 of a number equals 3 more than 1/4 of a number. What is the number? Right? So what this sounds like is somebody just read this off a page. 2 less than 1/3 of a number equals 3 more than 1/4 of a number. What is the number? Our job is now to write it so that it looks like one of these. Right? We got to write it so it looks like one of those. So let's go piece by piece. 2 less than 1/3 a number. Let's start with that. 2 less than 1/3 a number. 2 is just a number, less than 1/3 a number. We'll call number x. Now, I know the instinct, actually, you know what? I really don't want to write that in red since we just wrote that other thing all in red. Okay, there we go. I know it's instinct to think, okay, so it's 2 minus 1/3 x. But really think about what you're saying here. You have a number, x, you're taking a third of it, and then you're taking away 2, right? So it's actually the other way around. You have to be very cautious with less than, okay? Less than is very, very picky. To less a number, you're saying you have 2, you want less than that, right? But if it's less than a number, you are taking the number and subtracting 2 from it. So be super careful with the less than, okay? But I have my first expression, 1/3 x minus 2. Cool. Let's keep going. I have equals. Sweet. That equals is super important because it means equals. Fantastic. Moving on. 3 more than 1/4 of the number. Notice it says the number. They're telling you that it's the same number as the first one. So this is also x, right? Here's 1/4. More than means add it to, and the number 3. Now in this case, it doesn't matter which one came first, right? Because we have that commutative property of addition, right? We can write those in either order. So I think I'm just going to rewrite this as 3 plus 1/4 x. And I have my equation. Notice it was very easy for me to do that if I just pulled it right out of the problem. As I read, I pulled things that I know. Equals is an equal sign. More than, excuse me, I have a cough. More than is a plus, right? So if you pull stuff right out of the sentences, you can translate. You just have to watch out for keywords like less than. Less than, there's some other ones, divided by. You have to be very careful about what you mean by divided by. Things like that. Just go slow. Work very, very diligently and really, really think about what you're trying to say about the number. All right, so we translated. Fabulous. We are in Spanish, quote unquote. Let's go ahead and solve this, right? Let's answer it. So we've got x's on both sides. That's a problem. Let's fix that. I think I'm going to subtract 1/4 x to both sides. Let's see. Okay, over here on the right-hand side, I'm left with just 3. I'm going to zip over here. So 1/3 x minus 1/4 x. That's going to be 1/3 minus 1/4 x's, right? I can't really subtract them as they are, so I'm going to change them into fractions that can subtract, right? If you have 1/3 of the pie, you want to take away 1/4 of that, you're like, wait, what? Okay, hold on. So let's put this in pieces that are the same. So 1/3, they're both going to have to be over 12. And then, let's see, 1/3 is the same thing as 4/12, right? If I were to reduce it back, it would be the same thing. 1/4 is the same thing as 3/12. It looks like I'm left with 1/12 of the pie. So 1/12 x. Plus, oh, not plus, minus 2. If this part was confusing for you, adding and subtracting fractions, you need to come into tutoring. You have tutoring after school, you have tutoring before school, you have engagement, or that's engagement time, you have advisory time. You can go see any of the math teachers, you can actually go to the formal tutoring we have after school, you can email me, you can always email me, you can ask the sub, okay? This should not be super difficult, but if you can't do it, you need to fix that, okay? You need to fix it. Nobody can help you out but you, so you've got to come in and get that. Oh, sorry, I take that back. Nobody can do it but you, but people can help you out. All right, so back to the problem now. I will add 2 to both sides. Notice I'm still going as far away from the variable as I can. I end up with 1/12 x is equal to 5. Or in other words, x over 12 is equal to 5, right? Because that's the same thing. And then I multiply by 12 to both sides. X is equal to 60. So in order to answer the question, what is the number? The number is 60. And that's kind of where we translate back into Spanish, right? So we took some quote-unquote Spanish, it's English, right? We took some English, we made it into math, then we solved the math, and we translated it back into English. That's essentially how to tackle any word problem you could ever want. Not just the ones that translate directly, literally any word problem. Translate, solve, translate back. That's what you got to do. Alrighty, if you have any questions on this, let either myself or the sub know. You can email me anytime. We've talked about a lot today. Solving equations with some properties you probably knew already, but needed a refresher on and kind of figured out what they're actually called. We did that for quite a while. Talked about some cases where they don't work out, right? Some cases where you end up with no solution or infinite solution, right? We talked about rearranging formulas, so rearranging using those properties, and we talked about translating. That is it for 312. If you have any questions at all, you need to get them answered. Otherwise, you may begin your homework.